Okay, this is a problem number 23 out of your textbook. Graph f of x is equal to 2x plus 13 if x is greater than or equal to negative 5, and x plus 1/2 if x is less than negative 5. What this suggests to me is that there is a function made of two functions, and we have to make decisions about where each part is. So this one right here, the one in pink, suggests to me that we have a function, this function right here is to the left, to the right of negative 5, and this one is to the left of negative 5. So what I guess I would do first is realize that we have these critical values here, and the critical value here is negative 5, because that's where we're making our decision. So the first thing I would do is assess both of them at negative 5 and figure out which one counts. So f of negative 5 for the first equation would be 2 times negative 5 plus 13 is equal to 3, isn't it? 3. That gives us the point negative 5, 3. So here's maybe negative 5, 3. Negative 5, 3 here. And I guess my question here is, does this point count? How would you figure that out? You take the value here, negative 5, and that's the one that we're assessing here, and put it in and ask ourselves this question: is negative 5 greater than or equal to negative 5? And it is. And therefore, this one counts. And the notation for that is you take this hole right here and you just shade it in. And what you've said now is that this value on the graph does count. It says here that we need our graph here goes to the right of negative 5. So what's a number to the right of negative 5? And I don't know, 0 maybe? So I'll take f of 0, any random number that fulfills this condition. So I could try that too. I could say, I think I'm going to use 0, and ask yourself the question, is 0 greater than or equal to negative 5? And it is, so we can use that value, and we would have 2 times 0 plus 13 is equal to 13. And where is that? I don't know. It's probably way up here somewhere. So then I just connect this, and I believe we have the right hand side of the graph completed. Now try the left hand side. Do the same thing here. I'm going to assess this at negative 5 and then ask myself, does it count or not? So we'll get f of negative 5. This is us doing the left hand side, and that would equal negative 5 plus 1/2, which happens to be equal to negative 4.5. So we get the point 0, the point negative 5, negative 4.5. Negative 5, negative 4 and 1/2. Does this value count? The reason we chose this value is because it's a critical value. Now we decide, does it work? So ask yourself the question, is negative 5 less than negative 5? It is not. So this one, let me make this a little bit more clear. This one is a hole in the function. This value doesn't count. Now we need to assess some value. It says here, to the left. This is an arrow saying to the left. So to the left of negative 5, like, I don't know, negative 9 maybe? So I'll take f of negative 9. I could have used negative 90 or negative 990 or negative 7, but I chose negative 9. So here's the equation I'm filling in for it. So we have negative 9 plus 1.5 is equal to negative 8.5. So here's negative 9 over here. This is negative 5. This is negative 6, negative 7, negative 8, negative 9 maybe. Negative 8.5 would be down here, possibly. And I would do this. And pretend that touches, will you? Okay. So how did we do this? We assessed at the critical value. We went here and assessed them both. And that's how we got these 2 points. In the first equation, the pink one, negative 5 does fit this condition, and therefore the point counts. In the second equation, negative 5, which was chosen because it's the critical value, did not, so it made this open hole notation. Yes? Here, then we went back to here, chose points to the right of this. Why to the right? Because it says clearly to the right. And the same way that this second one says clearly points to the left of negative 5. I hope this was helpful.